what is simple interest, and then more importantly, what is compound interest. Simple interest isn't necessarily how the world works. Compound interest is where everything happens. So, what is interest to start with? Well, interest is the amount of money you receive. Like, let's say you have some cash. Let's say you have 10,000 bucks, and you give that to some institution, a bank or an investment firm or something. They're going to take your money and use it in some way. And interest, they're going to pay you for using that money because it's your money. You should get something for them using it. And you're also taking a risk by investing in anything, whether it's a bank or treasury bonds, anything. I mean, anything can happen. But anyway, risk is a totally different topic. But simple interest is I equals PRT. And I don't like the fact that I used capital letters. Usually principal is a capital letter, but rate is lowercase and time is lowercase. So interest stands for I, and then PRT is just multiplying P times R times T. So I is your interest, P is your principal or initial amount that you invest, that $10,000. T is your time, over however many years you're going to invest it, maybe 2 years or 5 years or 1 year or half a year, whatever. R is your rate of growth. Generally in banking, it is an APR, annual percentage rate. So always when you're doing, you want to check that out, but usually APR, that's annual percentage rate, so it's the interest you earn per year. All right, so let's say your grandma decides to give you some money. Okay, so she says, I'm going to give you $10,000, but you can't touch it for 4 years. And I have it in this really nice investment that grows at a rate of 12% a year. Grandma's a smart lady. Don't touch that money. 12% is pretty good. You won't get that hardly anywhere else. So anyway, you do interest. So to calculate how much interest you're going to have after that 4 years, you would take I equals 10,000 times 4 times 0.12, or $4,800. So you just multiply the three numbers together, and that's about how much interest you'll have. Now, simple interest is a linear function, so it's growing at a steady rate. Well, that's not how interest works. Interest is exponential, really. And that's what brings us to compound interest. So I'm setting up this table to help us understand compound interest. So let's say we have the same problem. We have the first year we have $10,000 that we put in the bank at the beginning of the year. At the end of the year, the bank calculates 10,000 times 0.12, or you earn in the first year $1,200 interest. And so you would have in the bank $11,200. Okay, so that's just in your first year. Now, this is assuming that we compound annually. I mean, there's all sorts of compoundings: quarterly, monthly, daily. Credit cards compound their interest daily. Most banks compound quarterly. So it all depends. So this is a really simple investment. They're just going to compound it once a year for you. So that means when you start year 2, we now have $11,200 in our bank or our investment. Okay? And so we're going to calculate, we get to the end of the year of that second year, and you're going to take 11,200 times 0.12. Okay? Now, the beauty of this is now we're calculating interest on interest. The $1,200 is interest, and we're going to take the 12% onto that. So we're going to actually make more money the second year. And in fact, if you multiply those two, you get $1,344. So now you add the $11,200 plus the $1,344, And now in the bank, we have $12,544 at the end of the second year. That's pretty cool. Starting to grow. It's growing more every year for us now because of the compounding element. Then the third year, we start the year with $12,544. Again, we get to the end of the third year, and the bank or the investment firm says, well, now we got to compound the interest. So 12,544 times 0.12, and now our interest is even bigger. And so it's $1,505.28. So at the end of that third year, our new bank statement says we have $14,049.28. Okay? So I'm adding, and again, if you're not sure how I'm getting that number, I'm adding 12,444 plus the interest we had earned on that account for a year. So now we're ready to start this fourth year. At the end of this fourth year, we can draw that money out. So we start the year with $14,049.28. We take that number times 0.12 for the 12, so we get to the end of the year. We take that times 0.12, and now we have $1,685.91. And now I'm starting to round to the nearest penny because that's what the bank's going to do. And so at the end of the fourth year, when we can draw that money out, we add these two together, and we get 16,000. Oh, sorry. Wrong. Sorry. $15,735.19. So just by compounding annually, compounding it each year, not touching it, we started out with a total interest of $4,800. You look here at this number with simple interest. But with compound interest, remember we started the year with $10,000, or at the beginning with $10,000. So with compound interest, we've earned $5,735.19 worth of interest. So that's a pretty big jump. And that's the beauty of compounding. Now, you don't have to compound annually. You could compound monthly, quarterly, and so that's the kind of the next step in this. I mean, that's all you'd have to do to understand compounding. You could sit here and chug them out no matter what. But let's say you had that same problem and you wanted to do it compounded quarterly. I'm not going to do that whole thing because it takes a while. But so we got $10,000 for principal. I said we're going to compound quarterly. The last one was compound annually. And like I say, most banks will compound quarterly, at least here in the United States. I mean, I don't know anywhere else. R is your rate of growth, and we'll keep the 12% because that's just kind of a nice number. And let's keep our time at 4 years. Okay. Well, the thing is, when you compound quarterly, we don't give all 12% interest in each quarter. We divide the 12% as an APR, annual percentage rate. So we've got to divide that up into 4 quarters. So, our interest for each quarter, if you were to set this up, let me just we'll get it started, and I'll let you, you could go ahead and finish this, but I am going to show you a formula where it all comes together. So, our first year, we're at $10,000 like we were before. But when we do our interest calculation, so this was that interest calculation, we're going to take that 10,000 now times not 0.12, but 0.12 divided by 4, because we're only going to do a fourth of it. And so that would be 0.03. So instead of 0.12 divided by 4, I'll put the 0.03 there. And so that is our quarterly interest. Each quarter we're going to gain 3%. What we're going to, and you might think, well, gosh, that's not as much interest. Well, the thing is, time is no longer in year, time is in quarters. And so if we're going to go 4 quarters for 4 years, we're going to have 16 compounds. And so now to do this problem, you have to put out 16 of these things. So 1, 2, 3, 4, all the way down to 16. And do it each time just like we did before. So like this 10,000 times 0.03 looks like $300. So that's the first quarter. But here's what's nice, is now you've got, for the second quarter, 10,300. And so you take 10,300 times 0.03. So we're kind of earning our interest earlier, because now you're going to take 300 times 0.03 before the year's even out. And so now this is even going to be more. And in fact, there's a formula, and I'm going to derive it in the next video, because I think it's kind of fun to derive those. But if you're interested in how we can come up with a formula for this, here's the formula that for compound interest. So your total amount that you invest, so principal is 1 plus your rate divided by your compounds to the compounds times time. So this is our total amount we're going to end up with. So in our case, our principal was $10,000. And you could do the table, but this works just as well. And I'll show you how to derive this in the next video. Plus, your rate of growth is 12%, so 0.12. Your compounds are 4. Remember, we did that up in the table. And then you'd also have 4 times the 4 years that Grandma has to let you keep that money in the bank. And so you've got 10,000 times 1.03, because 0.12 divided by 4 plus 1 is 1.03, to the 16th power. And so you pop that baby into a calculator. So 10,000 times 1.03 caret 16, and you get $16,047.06. So now we're up to, by compounding it quarterly, keeping everything else the same, but just changing our compounds to 4 times a year rather than once a year, now we're up to $6,047.06 worth of interest. So it makes a lot of difference how often you compound it. So imagine compounding it weekly. So weekly, there's 52 weeks in a year. So instead of a 4, you'd put a 52 here. And so if this was your compounds, instead of a 4 here, you'd have a 52 here. And so that's going to be even more money. But eventually you run into a diminishing returns. I mean, it's not going to make as much of a difference by compounding it weekly as opposed to quarterly. It will make a difference if you're dealing with a lot of money. And that's why credit cards go with daily, because they're dealing with billions and billions, maybe trillions of dollars. And so they're going to compound daily because those couple of pennies for them really add up. So that's compound interest. In the next video, I'll show you how to derive this formula for figuring compound interest. And because it's kind of a fun little algebra project. And I hope this helps you understand compound interest and the beauty of it. It is a beautiful, beautiful thing. And I'll see you next time.